guys, good morning. If you are watching this video, that means you have just completed your second Fantastic Five of the week. This is actually your first review video for Fan 5 this week, because yesterday we did a live Zoom going over the Fantastic Five questions. So yesterday's Zoom was completely optional, but I said in the announcement, if you want to get better, if you want to take notes, if you want to put yourself in a better position to get a 5 on Friday, go to that Zoom, because it's going to be the same thing that I would provide in the video. Now, if you have not done Tuesday's Fantastic Five, make sure you stop, go knock out those questions first, then come back and watch, because again, this video is really going to put you in a better spot towards the end of the week so you can get the best score possible. Obviously, that's the goal. And as these Fantastic Five questions start getting more challenging and they start getting more difficult, you're going to need these videos, because there's going to be days, and maybe today was one of them, where you have no idea how to solve a question. Or you have an idea, but you get to a point and you get stuck. This is what these videos are for. So I may show you a way that's a little bit differently than the way you solved it. If your way works, do it. That's fine. But if maybe you missed a question on Monday, you missed it today as well, and you want to give my way a shot, I think it's a good idea. It's worth a try, because really the only day that matters is Friday, which we know. So questions 1 and 2 are going to be pretty important, because it's going to go with what we're learning in class this week. And with multiplicative comparisons, it's a mouthful, multiplicative comparisons, practice really does make perfect. And it's not really a difficult concept if you can do one thing, which I'll show you in just a second. A lot of students make this harder than it has to be. If you can identify certain keywords in a question and use a certain picture, and you know your multiplication, this gets a lot easier. So again, practice makes perfect. I'm gonna stop running my mouth. I'm gonna get right into it. Yeah, I got my cold stuff on. We lost yesterday, whatever. All right, number 1. It says Amari has some Skittles. Mahogany has 5 times as many Skittles as Amari. Together they have 30 Skittles. How many Skittles does Amari have? The most important words in this question are times as many. Whether it says 5 times as many, 10 times as many, it doesn't matter. Times as many makes a light bulb go off in my head. When I hear those words or see those words times as many, I instantly think box method. I want you to start thinking box method. Now, you're going to hear people call it a few different things. Some people call it the bar model. I just call it the box method. But when I see times as many, I know that 2 things are being compared here, either 2 people, 2 objects, 2 weeks. In this case, it's 2 people. I'm comparing the Skittles that Amari has and Mahogany has. So what I would do is I'm going to pull those 2 people out. I'm going to put an A for Amari and an M for Mahogany. Now, it says Amari has some Skittles. We have no idea how many that is. Okay, so the next sentence tells us Mahogany has 5 times as many. Now, if Mahogany, has 5 times as many, she gets 5 boxes. That's why we call it the box method. So Mahogany 5 times as many, 5 boxes. Now, whoever gets that amount of boxes, if it says 5 times as many, if Mahogany gets 5, that means the other person automatically always gets 1. And you'll get to see this again in just a second. All right, so again, I'm just taking the information that it gives me. It says together they have 30 Skittles. So that doesn't mean that Amari's box represents 30. That doesn't mean that just Mahogany's boxes represent 30. That means both boxes combined together are 30 total Skittles. Now, when I look at that 30 and I look over at the boxes, I've got 1, 2, 3, 4, 5, 6 boxes. I've got to take those 30 Skittles and split them evenly into those 6 boxes. And when I say split them evenly, one operation should come into mind. If you think about last week, we've got to divide. And we're going to divide by 6 because that 30 represents both of them, 30 Skittles together. So here's where knowing your multiplication really helps. If you do 30 divided by 6, that gives you 5. And that 5 means that I'm going to put 5 Skittles in each box. The important part is the question, because sometimes it might ask Mahogany, sometimes it might ask Amari. In this case, it says, how many Skittles does Amari have? All you got to do is look at the picture, and that answer would be 5. Now, I could have made this a little bit harder on you with the answer choices, because some people might look at Mahogany's boxes and give you an answer of 5, 10, 15, 20, 25. So that wasn't even an answer choice. It wasn't even an option. So you've got to make sure you're reading that question carefully because you were looking for Amari there. So times as many, you're thinking box method, and whoever has that certain amount times as many, they get that many boxes, and the other person automatically gets 1. Now, this can look a couple of different ways, and number 2 is another example of that. So if you look at 2, it says Laura changed 32 diapers. That is 4 times as many diapers as Mr. Huber. How many diapers did Mr. Huber change? So, times as many. Again, you should instantly think box method. 2 things are being compared here. We're comparing the amount of diapers that Laura changed and that I changed. So I'm going to pull the 2 things out. I'm going to pull Laura out. I'm going to pull myself out. I'll put H for Mr. Huber. Now, remember, the number of boxes comes from the times as many. Now it says 4 times as many, meaning somebody's getting 4 boxes. If it says that Laura changed 32 diapers and that is 4 times as many, that means that Laura gets the 4 boxes and I will automatically get 1. Now, on the last question, the 30 Skittles represented both people. It said together they have 30. In this question, those 32 diapers only represent Laura. That has nothing to do with me. It says Laura changed 32 diapers. So instead of doing this thing right here, equal to 32, I can't do that because, again, that doesn't include me. I'm just going to have it equal to Laura's boxes like this. Again, don't know anything about me yet. So now what I have to do is I've got to take these 32 diapers and split them evenly in between Laura's 4 boxes. It has nothing to do with mine. Again, if you know your multiplication facts, this gets a little bit easier. If I do 32 divided by 4, that means that every box is going to have 8 diapers inside of it. And if Laura's boxes have 8, that means my box has 8 as well. So if the question says how many diapers did Mr. Huber change, all I have to do is look at the picture, and that answer would be 8. And it's not going to ask you how many did Laura change because it already gave us that information. Now, there could be a question like this where it said how many diapers did they change combined? Well, it gave us her 32. We just figured out it was my 8. I could add those together and get 40. So the question can go a bunch of different ways. I don't expect this question, 1 or 2, to be super high this week. Honestly, there's a really high chance that you're going to see a question like this again next week in Fantastic Five. We're going to be working on it in class for probably multiple days. The most important thing that you can take away from this little 1 and 2, when you see times as many, I want you to think box method. The more you practice this, I promise you the easier that it will get. It's really tough for you to be doing this virtually because I like being able to see your notes. So I'll give you a little ticket opportunity here. If you send me a picture of your work for 1 and 2, trying the box method, I'll give you 50 tickets. I would love to see you trying to use that. So if you do that, 50 tickets, boom. All right, moving on to number 3. Believe it or not, this one is still giving us some trouble. And we've spent the better part of maybe 2 school weeks working on it. We just tested on it last week. Some of you tested on it today. But when we're talking about finding the factors, again, factors are the numbers that you can multiply to get 16. I've solved it the same way every single time. I'm still going to solve it the same way. I'm not even going to look at the answer choices. If I know I'm dealing with 16, I'm going to start with the first factor pair, 1 times 16. All right. Then I'm going to try 2 times something because it's an even number, and I know that 16 is a multiple of 2, and I know my facts, so I know 2 times 8 would work. Now, I would try 3, but if I listed my multiples of 3, I would never land on 16. Then I would try 4, which would work because 4 times 4 gives me 16. I know I'm done right here because there's no number that falls in between 4 and 4. That's the same number. That means I'm done. There's no more numbers I can try that are going to go in evenly. Once I've got my factors, I list them in order, least to greatest. You can put the 4 once, you can put it twice. Doesn't matter. But if you're looking at your answer choices, looking at A, you're missing 4, can't be right. B looks pretty good, 1 times 16, 2 times 8, you've got your 4 in there. C, you're missing an 8, that can't work, you gotta have 2 times 8 in there. And then D, you're missing 1. I think that's the mistake that we saw the most last week, people forgetting 1 as a factor. Guys, 1's always gonna be a factor. It's one of the first ones you should list. So that's gonna give you the answer of B. Some people might miss that because they only see the 4 one time. Guys, you only have to see it once. If you put it twice, like as an answer with no answer choices, I wouldn't count it wrong, but you don't have to put it twice. So that one would be B. That's one, honestly, I think that's the one that could save you from not getting a 0 today. I think everybody should be able to get that one correct, but if not, that's why we're working on it. So moving on to number 4, one thing that is always a bit of a struggle with 3rd graders who come to 4th grade is geometry. So all week long, number 4 is going to be a geometry question. And what I tell you today could actually help you in the next few days with those questions. Because if you don't know what something is, I'm going to tell you right now. So it says, what shape does not have exactly 2 sets of parallel sides? So first of all, a set would mean 2. So if you've got 2 sets, that means you've got 2 pairs. And if you didn't know what parallel sides meant, then you wouldn't be able to solve this question. You might just be guessing on this one, but that is something that you learned last year. If you have sides or lines that are parallel, they're the same distance across the entire path that they travel, and they will never intersect. So if you've got lines like this, let me see, these would not be parallel because if they kept going, eventually they would intersect. If you've got lines like this, they wouldn't intersect this way, but if I extended this way, they would intersect. So parallel lines, same distance across, both directions, never cross, never intersect. So if you look at a square, I might actually be able to do shapes on here. No, I can't, but I'll just draw. So with a square, now I'm going to try and be as even as I possibly can. Yikes. All right, so that's my square. It's supposed to have 4 equal sides. But if you're looking at the top and the bottom, which let me change my color. The top and the bottom, they're parallel. They would never intersect. That's one set. And then if you look at the sides, same distance across, never intersect. That's your second set. So that can't be my answer. Let me get rid of the square. And that one you're probably pretty good on. Ooh, I might have a rhombus right here. All right, so my rhombus here is kind of tilted. I don't know if I can rotate it. I don't think I can, but you got to kind of turn your head this way, like when a dog hears a whistle. Anyways, here's a rhombus, very similar to a square. It's got 4 equal sides. It just doesn't have 4 right angles. But if you are looking at these 2 sides here, same distance across, they would never intersect. That's one set. And then the one this way, same distance across, never intersect. That's 2 sets. So that cannot be my answer. Now with a rectangle, you have the same deal here, top and bottom. That's an awful line, but top and bottom are parallel. That's one set. Your sides, those are also going to be a set of parallel sides. They would never intersect. That's going to leave you with an octagon, which I think I can pull up a picture real quick. Now, if you have a regular octagon, that's what it's called, a regular octagon. Here we go. Stop share. Oh, hey. An octagon has 8 sides. And if it's a regular octagon, that means that it has 8 sides that are all equal length. And if you have a regular octagon with 8 equal sides, that means you're going to have 4 pairs of parallel sides because they're all going to be parallel. So I'll map them out for you right here if I can get this away from me. Here we go. All right, so you got one set here. Boom, boom. There you go. There's one set of parallel sides. Then you go boom, boom. There's 2. Boom, boom. There's 3. Boom, boom. There's 4. So my picture was pretty offline, but if you have a regular octagon, that means you would have 8 equal sides. That shape would have 4 sets of parallel sides. So I think tomorrow what you'll need to know for your question and for the rest of the week, you got to know what an octagon is. And if you know octagon, you got 8 sides. You're going to have to know what parallel sides are. You're going to have to know what parallel sides are. They never intersect. That one could go either way, because that is something you should have learned last year. I don't know if that falls in the virtual portion of the year, but that one could get us to a 1 or a 2. All right, number 5, I think, will be not the most challenging, but maybe the one that gives people the most frustration because they're going to think there's maybe not an answer, but I'm going to show you ways to figure out what you need to do. You're going to have a mental checklist in your mind of what you need to do when you come across certain situations. So the first thing, the question says, which picture below has a pizza that shows 1/3 eaten? Now, this is the word's in all caps because it's important. Guys, if there's 1/3 eaten, that means it's gone. That means you cannot see it. A lot of people get the pictures confused. Like they might look at pizza 3 right here and say, ooh, that pizza represents 1/3 because there's 3 total pieces and we can see one of them, 1/3, but that's not 1/3 eaten. That shows 1/3 left. So let's look at these pictures. And if you watched the live Zoom yesterday, I gave you a couple of hints and tips of something that you can do, which is kind of hard to do virtually, but you can kind of just do it and trace it with your finger. What I would do is these little lines that are in the pizza, excuse me, I would extend them just so I know exactly how many pieces of pizza are missing. So like this one that goes right across the middle here, that one I can see that whole line, but this one right here, I'd go ahead and extend. That way that I know, and again, my fingers are too chubby to be writing on the screen, but that way I would know that there's 2 pieces missing. Just like that. So when we're getting a fraction, you've got your numerator, you've got your denominator. Your denominator is always going to come from how many total pieces there were. So if I'm looking at this pizza, 3, 4, 5, 6. There were 8 slices, which means it was cut into 8ths. So my denominator would be 8. And if we're talking about what was eaten, now what's left, there are 1, 2 pieces that got eaten. That picture represents 2/8. All right, so I do the same thing for the rest of the pictures. Oops. So if I'm looking at pizza 2, get out of here. Get out of here. Again, I'm going to get my fraction. Denominator comes from how many total pieces there were. There were 1, 2, 3 pieces there because that pizza was cut into thirds. And then how many of it was eaten? 1 slice is gone. So it's pretty clear the pizza 2 is what I'm looking for. That would be my answer, but I'm still going to check for pizza 3 and pizza 4. And I already talked about pizza 3, but I'll do it again. You know your denominator is going to be 3 because there were 3 total slices. But if it's talking about what was eaten, there are 2 pieces missing. So that would be 2/3, not what I'm looking for. And then for pizza number 4, the fraction that was eaten here, your denominator would be 4 because it was cut into 4ths, 4 slices. And if we're talking about what is eaten, that would have been 3/4. So the pizza that shows 1/3 eaten would be pizza number 2. I think the thing with this question is it's going to be important to look at that last word, whether it's talking about what's eaten or what's left, because if you read it wrong, you might do perfect math and get the question wrong. Yesterday, if you watched the live Zoom, you're realizing that you didn't have to do something today that you had to do yesterday. That gives you an advantage going forward on Wednesday, because you may, if you did not come to the live Zoom, you may see something funky tomorrow, and you might think that there's not an answer. But there's a little tip or trick that we learned on Monday that can help you. So if you think there's not an answer on when tomorrow's Fan 5, I promise there is, but the review video will help you figure that out. So it's very important that you watch those. All right, so the first review video of the week is always the longest. So if you sat and watched this, I appreciate it. It's going to help you in the long run. So they will get shorter as the time goes because there's not much explanation as we go moving forward. If you have questions, keep watching the videos, send me an email, Zoom with me, anything that you need. That's what I'm here to do. Thank you guys for watching. Good luck tomorrow.